now. Okay, so we've closed up, I'd say 1/3 roughly of unit 1 that has to do with inequalities. And basically what we saw there were the definitions of inequalities associated to them, number of types of numbers, etc. We also did some exercises having to do with linear inequalities and nonlinear inequalities. So we're wrapping that up. And that was homework task, or that is homework task number 3 and workshop 2. Now we're going to jump over to a next topic, which is the topic of absolute value. Okay. Can anybody tell me what you guys remember an absolute value is? What's on the screen is I think the mathematical definition of absolute value, but what do you guys remember of an absolute value is? Anybody, either here or at home?
It was up to positive.
Okay, could you
That
say that louder?
the sign always turns to neutral.
Sign always turns to neutral. Say it again.
They always have to be positive.
Okay, over here, I'm really bad with the names. So if I'm asking about the names, it's not because it's just that I'm really bad with names. So it's Ivan.
Yes.
Ivan, okay. I usually learn the names about the 3rd or 4th semester I'm teaching students. That's because I'm bad. Ivan. So Ivan just mentioned that it always turns positive. Okay. And over there at home, who spoke? The mention about the neutral, who spoke at home? Miguel. Okay, Miguel. That mentioned about the neutral. And go ahead. And again, we're going to be trying them. So Daniel, right?
Yes.
Daniel.
So it's the value it represents in the line. It doesn't matter if it's positive or negative. It's the value it represents.
That's a good. Everything you guys said are correct, and Stephen approaches the same definition. But I'm going to take what Daniel said, and you mentioned that regardless of where the number is in the number line, it's the value, not the position. So let's go with that. Let's go with that because the absolute value seems like something very simple, but once we start using it in inequalities, the thing that seems very simple starts to get a little bit confusing. So I'm going to take what you said, Daniel, and do this. Let's draw a number line here. And the reference of the number line is a 0. Okay. Now, let's see, Fernanda, are you there?
Yes, teacher.
Hi, Fernanda. Question. Give me your favorite number.
14.
14, perfect. So I'm going to take Fernanda's number. And you just said 14, right? I didn't ask you the sign of the number. I just asked you your favorite number. Usually this is interesting because if I ask Fernanda, what's your favorite number? You said 14, right, Fernanda? Wouldn't it have been weird if you or anybody else said, well, I like -22? That would be an odd person, right? But it's not. Well, it's odd, but it's not wrong. But we usually think with regards to positive numbers, right, Fernanda? So you said 14, you didn't say -14, right? You said 14. And 14, we just placed it in the number line, okay? Now, I'm going to stay with Fernanda. What is the distance if we were to measure from 0 to 14? What is the distance from 0, which is a reference, to 14? How many, let's assume that those are meters. How many meters do I have from 0 to 14? It's a very simple question.
14.
14, right? It's 14 units. That's the distance. We agree? It's a positive number. Now I'm going to take Fernanda's number. And if you're familiar with pop culture stuff, we've got the normal universe and then we've got multiverses. And there are usually dark universes. So there's a dark version where I ask Fernanda, a multiverse where I ask Fernanda, what's your favorite number? And she says -14. And why? Because it's a multiverse. And so she says -14, and we go over here. Why? Because it's another universe. It's a parallel universe, and over there in that universe, negative numbers, you answer negative numbers. You don't say positive. And so we've got the -14, which is still Fernanda's number. but it's negative. I'm going to ask you, Fernanda, let's do some role playing here. Now you're in the multiverse. Now you're Fernanda that answers minus 14. What's the distance between 0 and minus 14?
14?
It's still 14 without the question mark at the end. You have to say it's 14. It's 14. So regardless of if it's positive or negative, the distance to 0 is the absolute value of the number. That's why it's called absolute value. And so regardless of if it's 14 or minus 14, the distance to 0 is 14. This is the absolute value. Is that clear? And it has to do with what you were mentioning, Daniel. Regardless of if it's positive or negative, we were just interested in the value. And actually that value represents the distance to 0. Okay? It represents the distance to the 0 reference. And that is the absolute value. And how do we represent that? Well, we represent that with these bars. So the absolute value of 14 is 14. And the absolute value of minus 14 is 14. Okay, are we clear there? Thank you, Fernanda, for doing the normal universe and the multiverse thing. Thank you. You're free. You're free to return. So is it clear? Is the concept clear then? We're talking, and now mathematically, it also has to do with what Ivan and Miguel were mentioning. Another way of looking at it, it's always going to be positive. So anything that's within the bars is going to automatically be turned into something positive. Or another way of looking at it, which is how we're going to see it with inequalities, is that whatever is within the bars could be positive or negative, but in the end, the result is going to be positive. Okay? Questions up to this point, are we okay? Okay. It's absolute value with an E, not absolute value without an E. That's a totally different course that has to do with chemistry. Okay. If you understood that joke, good. If not, Google it. Okay. And if you didn't understand it, I'm glad, because that means you guys are very innocent and don't drink. Okay, so that's good. So absolute, that's what I meant. Let's go back there. Just give me one moment, because I drew using the PowerPoint tool, and I really detest that because it does weird stuff to my PowerPoints. Give me a moment. I'm going to share the screen again. Give me a moment. Okay. Now we're talking. Now, always when we're going to be talking about mathematical relationships, rules, or whatever, or concepts, these have properties. And so, again, the properties are things we normally use without thinking of them, but it's good to review them. Okay. So, what are the properties of the absolute value? Well, property number one is the one that I already mentioned. The absolute value of A is equal to the absolute value of minus A. So, and we just mentioned that. The absolute value of Fernanda's number 14 is 14. The absolute value of the negative version of that, the absolute value of minus 14 is 14. So both absolute values of a positive and negative are equal. The second property, or theorem, so we already did this one. The second says that the absolute value of a number is 0 only if the number is 0. that might seem overly simplistic, but it's important. So the only way an absolute value is going to be zero if whatever is inside the absolute value is zero. That's going to be the only condition. This is important because remember when we were working with the inequalities that we sometimes struggle with, can I multiply? There are things that we do with equations that we can't do with other types of expressions. We notice that with the inequalities. So there are certain properties that are going to apply to absolute values that we have to keep in mind. So for example, the commutative law, meaning if I have the absolute value of a product, I can separate that into the absolute value of each of the numbers, okay? So let's just do an example of this one. I'm going to use Fernanda's negative number, and I'm going to use my favorite number. I'm going to use the negative version of Fernanda's number. And I'm going to use my favorite number. Can anybody guess what my favorite number is? No, it's like, no, that's my wife's favorite number, 13. No, it's between 0 and 10. No, keep going.
7,
Now, eventually you're going to get there.
5.
No,
7,
no, 2. It's 2. Eventually, if we started talking, we would get there. That's the way. That's the way the magicians. That's if you just Google Penn and Teller, and there's some documentaries of how magicians do that thing where they seem like they're reading your mind. It's called a cold read, and that's what they do. And so what's my favorite number? It's between 0 and 5, and then you suddenly say 2, 3, and then we get to the number, and everybody's like, oh wow, he's reading our minds, and it's not that. It's going to be a 2. My favorite number is a 2. Why is that? I'm really not into numerology. But it's weird. My birthday is the 22nd of February of 1975, which equals 22, which is weird.
I was born on the 4th of April,
4th of April? What year?
2003.
That was close. That was close. Yeah. And again, I'm not really into numerology. I'm a little bit superstitious, to be frank with you guys. But yeah, I've always liked the number 2. So you like 13?
Mine.
You like 13?
Yes.
Yeah, my wife likes 13 a lot. That's why we want to have the baby on September 13th, because that way he's going to have birthdays on Friday and Tuesday the 13th. So yeah, we're like that. If we multiply these two numbers, this is minus 28. And the absolute value of minus 28 is 28. However, if we apply the property, that means that this is also equal to the absolute value of minus 14 multiplied by the absolute value of 2. The absolute value of minus 14 is 14. The absolute value of 2 is 2. And that means that this is 28. Okay. Same thing happens with the division, as long as the denominator is not 0. Okay. Now, number 5. I'm going to put that in a different color. Number 5. Number 5 is called the triangle inequality. This is going to be a bonus for exam number 1. If you can do the demonstration or the explanation of that, and you can Google it and research it, just think about it, and when you get to the exam, know how to write that down. That's going to be a bonus for exam number 1, the triangle inequality. Why does A plus B? So something very important here. The absolute value of A plus B is not A, the absolute value of A time plus the absolute value of B. That is not equal. However, this does apply. Somehow the absolute value of A plus B is less than or equal the sum of the individual absolute values. And that's a property. It's called a triangle inequality. And that's going to be, if you guys can do that, that's going to be a bonus for next.
The bonus.
So the bonus is going to be in the exam. There's going to be a last problem that's going to say demonstrate the triangle inequality, and you have to do the demonstration of how you get from the left side to the right side. And again, that's totally optional. Okay, let's jump over then and continue. Okay. Now we're going to try some equations. Okay. To solve some equations. How could we solve? These are not inequalities yet. These are just equations that have to do with absolute values. Okay. And the thing with an equation with an absolute value is that in most cases, there's going to be more than one solution. So let's, I'm going to give you 2 minutes to look at these and see what you can do, and then we're going to solve them here. Okay, let's see what we can do here with these two equations. And again, we're not yet working with inequalities. Right now, we're working with equations, absolute value equations. Let's see what we can do there. Let's start off with the first. Well, the thing when we're given an inequality, an inequality that I'm sorry. When we're given an absolute value equation, is that we need to remember that the value that's inside the absolute value can be positive or negative, but regardless of that, it's going to turn into something positive. So I'm going to go back to what we were discussing about when I asked Fernanda about her number. So when we placed it in the number line, it was 14. If we placed the minus 14, the absolute value was 14 as well. So that means that both the 14 and the minus 14 comply, or the 14 rather would comply with the minus 14 and the 14 with regards to their absolute value. So we need to consider that when we're solving equations. So basically, we've got the absolute value of 5x minus 3 equals 8. Okay. If this were a normal equation, then we would have 5x minus 3 equal 8, and then we would just solve it for x. Okay. However, we need to remember that this is an absolute value. And this means that this equation is we're going to always the absolute value, we're going to have to break it down into the two versions, the positive and the negative. I'm gonna write it down I'm not gonna write it down as steps, but in the video, I'm gonna be mentioning them as steps. So the first thing is that we need to break down this expression into two versions. Version 1 is the positive. It's Earth 1. It's the normal. It's our normal main universe, and that would be 5x minus 3 equals 8. That's the positive version of the expression. And then over here, we're going to have the dark multiverse, and we're going to have the negative, or the dark ether version. And basically for the negative version, the only thing we need to do is multiply by -1. Now, here's the thing, so we don't get confused and don't get into a really complicated philosophical discussion, mathematical philosophical discussion. When we're going to do the negative, we can apply the negative to either side of the equation, and it's going to give us the same result. Notice that I said either side, not both sides. So what I'm going to do now, just to make it easy, I'm going to apply it to the right-hand side that has the 8. So the negative version would be 5x minus 3 equals -8. That's going to be the negative version of the inequality. If we would have multiplied the 5x minus 3 times -1 and left the 8 as 8, it's the same thing. It's in the end, the solution would give us the same thing. And here, what we need to do is just 5x is equal to 8 plus 3. 5x is equal to 11, and x equals 11. X equals 11 divided by 5. That looks like a little face. That's the first solution. Remember, the equations with absolute values, you're going to have more than one solution. Okay, so the first solution, or the first value of x that complies with the expression, is x equals 11/5. Now over here on the negative side, we're going to have 5x equals -8 plus 3. 5x is going to equal -5. X equals -1. These are the two solutions to the expression. This means that I can substitute 11/5 into the original expression, apply the absolute value, and I'm going to get an 8. That means that if I substitute the -1 into the expression and then apply the absolute value, I am also going to get an 8. Okay? Both are solutions or a part of the solution set. Okay? Questions with this one? Over here or at home?
Teacher,
Yes, go ahead, please.
I think it's a dumb question, but where
There
you
are no dumb questions, Alfredo. There are no dumb questions. Okay, so go ahead.
well, you put a positive side and a negative side.
Yes.
I thought that in the positive side, it would be 5x plus 3, but
Oh.
it stayed the same. Why does it stay the same?
Okay. In the case of the positive, saying it in a very simple way, in the case of the positive scenario, Alfredo, the expression is exactly as you have it here, but without the bars. The positive scenario is 5x minus 3 equals 8. You don't have to do anything to it. Okay? You're not gonna modify anything. It's the scenario where what's inside the absolute value is positive. So imagine that you're multiplying it by +1. Do you agree, Alfredo, that if I multiply anything by +1, I'm not going to affect anything, right? So that's why it stays the same, okay? Are we okay up to this point?
Yes.
Now, on the other side, on the negative scenario, I'm multiplying or I'm considering that it's negative. So I am going to grab what's here on this side and I'm going to put a negative sign on it, okay? And that's going to be the negative scenario, assuming that it's the other value. Remember when we were talking about the numbers, the positive scenario is when I put a number here. Is when I was asking Fernando, what's your favorite number? It's the 14 that she said. The negative scenario is I'm going to grab exactly that same thing, but I'm going to put it on the other side and put a negative to it. That's what we're doing over here. In the case of the positive, we don't do anything to it. We just remove the bars. Okay? Is that okay, Alfredo?
Yes, yes. Thank you.
Good. I'm going to take a screenshot of this. So. This is another class. Okay. Questions up to this point? Okay.
On the exam, you have to put either or. You have to put both.
No, both. That's an important. That's an important question. Okay. Again, I'm going to be very bad with the names. Keep telling me the names. Arturo. That's a very important question. In the case of an absolute value, it's not one or the other. Both solutions are part of the solution set. So, for example, if you just did the left part, then it's not correct and it's incomplete. We're always going to have a solution set. What does a solution set mean? It means it can be one or many values. So the complete solution is both of them. Okay. Yes, Daniel.
It's like formula central.
It's like correct. That's a good example because sometimes when we're solving a trinomial that or any sort of polynomial that's to the second power, then we're always going to have two roots. When we apply the general formula has a plus and a minus. So we're always going to get two values. Okay. A common mistake as well, not mistake, but a common thing. Daniel, if we're going to be very strict with math terms, just to go with your example, which I think is a good one. Let's say I give you this. Mentally, quickly, what's the solution to that? No, it's +2 and -2. How do I solve this? I apply a square root here and a square root here. The square root by default is going to have a plus-minus solution. We forget that. The complete solution is +-2. This has two solutions. A square root is always going to have two solutions, the positive and the negative. And so sometimes when we solve a polynomial, we always just get the positive value. I noticed that in one of the solutions, one of the problems, one of the houses, we always have to remember the plus-minus.
Yes, I don't know. Problem on inequality that I solved with roots.
Mm-hmm.
So I had to put both.
So if we were doing this in an inequality, we would need the minus infinite to -2 to -2 to 2 and 2 to infinite. We need to consider all of those. That is important. Both of them are part of the solution. Okay, it's a good observation. Okay, now let's look at the next example. Okay, we've got the absolute value of x minus 4 is equal to minus 3. What do we do there? Anybody got any ideas?
Well, I separated like the previous example.
Okay. You separated it into both, into two.
So positive
let's-
and negative.
Huh? Could you say that again, Alfredo?
I separated the equation into two. I made a positive version and a negative version.
Okay, we could do that. But let's look at the inequality. It says the absolute value of x minus 4 is equal to minus 3. One thing that's important from now on, that you're in engineering, because you're used to seeing math, but you're used to seeing math very procedurally. We as engineers, math is a tool, and we need to go a little bit deeper and try to use our critical thinking to link things. Not everything can be solved using a procedure. Let's look at that inequality. I'm going to ask you the following. You raise your hand? Oh, sure. Let me ask you the following. It says the absolute value of x minus 4 is equal to minus 3. Can an absolute value be negative? Yes or no? So is there any number that is going to satisfy that equation? Is that clear, everybody here in the over at home? Is that clear? I've got an inequality. This is kind of a trick problem, okay? I've got x minus 4, the absolute value of x minus 4.
Give me a moment, I need to stop screen sharing and I'll do it again.
So I've got the absolute value of x minus 4, which is this. And I'm saying it's equal to a negative number. This is impossible. Meaning, an absolute value of a can never be negative. Okay, the absolute value of a can never be negative. Okay, I'm gonna do a screenshot of this, so I wrote this down really ugly.
So if we were to solve that, it would give us the solution for 3.
Correct. If we were to do what Alfredo was mentioning, we're going to do the separation and do the procedure. We would have gotten the solution for 3, not minus. And actually, yes, we would have gotten the solution for 3, not minus 3. And minus 3 is impossible. So this, I'm just going to write it again because the other, I didn't like the way it looked. This is impossible. The absolute value of any number can never be negative. The absolute value of anything can never be negative. Therefore, there is no solution. Or the solution set is empty. Okay. This one was kind of a trick one, okay? So it can never be negative, so there is no value I can substitute there for the x that is gonna give me a -3 because there's the absolute value there, okay? Screenshot of this. Questions with this one before we? Now we're going to start talking about inequalities. And so kind of the same principles apply with inequalities with absolute values. We need to consider the positive and the negative scenarios. Just that there's going to be basically two situations. Sorry, there's going to be two situations that we can have. Either the absolute value is less than or equal, or the absolute value is larger than or larger than. And so going back to the example we were talking about the number line. In the first case, when it's less than, I'm going to have a 0 here. And I'm going to put the two numbers, and I'm going to use Fernanda's numbers. I'm going to use -14 and 14. If I'm talking about the value, which is 14, in what range is the distance less than 14? In this range here. And so the range is between -14 and 14. So that's the case when it's less than. When an absolute value is less than, or the absolute value is less than a number or a value, then the representation of that is that it's going to be between the positive and the negative of the values. That's the way we're going to interpret or consider the negative and the positive. If the absolute value is larger than, now I'm going to use my number. I'm going to have a 2 and a -2. Then the values where the distance is larger are going to be these values outside. And so that means that x is less than -2 and x is larger than 2. Those are the two situations that we're going to have, and we're going to separate the inequalities depending on that. And so in the next couple of examples, it says, find the equivalent inequality expression for absolute value of x less than 1. And when we say equivalent inequality expression, basically we're saying represent that inequality without the absolute value. Remove them, and how would it be equivalent? Okay. And the same for the absolute value of x larger than or equal than 5. Now, based upon that, can somebody tell me how we could express, based upon what we just talked about, how can we express how can we express this first one? Absolute value of x less than 1. How would that be equivalent? Go ahead, Arturo, right?
Yeah.
Arturo.
-1 less than x less than 1.
Okay, so what Arturo is saying is that this would be equivalent to saying negative. I'm gonna write both of those in green so we know that. Blue and underline. So Arturo is saying that this would be equivalent to saying -1 is less than x and less than 1. Since it's less than, then we're taking the intervals between the negative and the positive number. That's that would be correct. That would be correct. Good job. Now, how could we represent the next one, which is absolute value of x is larger than or equal than 5? Anybody? Arturo again, go ahead.
It's going to be x greater than or equal to
Could you say that again louder?
x greater than or equal to 5.
That's half of the solution.
Or it's x less than or equal to negative.
Correct. Both of those are the solution. So we would have x is less than or equal than -5, and we need to include the equal because the inequality is mentioning it. X is less than or equal than -5, and x is larger than or equal than 5. Those two cases consider both the positive and the negative. And so whenever we have an inequality that has an absolute value, we're going to remove the absolute value by applying these two principles or theorems. Okay, let's look at some examples. Before we look at the examples and before I forget, before we look at the examples and before I forget, because we're going to be doing some exercises, we're going to deploy homework task number 4. And this is actually a very short homework task compared to the other one. Homework task number 4 is going to be for Wednesday the 15th. So it's next week. Okay. It's a very small homework task. It's already in Blackboard. It's, I think, about half of the problems that you did or less than the ones you did for homework task number 3. So it's not that long. And we're going to be doing a workshop. And so for next class, meaning for Thursday, in houses, I want you to try to do those 2 problems that are listed there in houses. Same dynamic for the workshops. Try to do the problems, bring them in a PowerPoint. If you get stuck, we'll get through them here. Okay, it's just 2 problems this time. Okay, and we're going to start with some examples today. Okay, this is in the PowerPoint. I'm going to take a screenshot of this. Send it in the chat. And I'm also going to take a picture and send it to the WhatsApp. This is for next. This is for next class. So let's look at some examples of, as to how to solve some of these inequalities. So, let's look at these three examples.
Make a correction here.
Okay, let's do these three examples to start off. I'm going to give you a couple of minutes to try to do those in your notebooks, and we'll begin solving them here in a moment. Remember to apply what we just talked about. And remember that you may ask questions as well. Let's start off with the first one. So I've got the inequality, solve 3x minus 7 is less than 1. And so what we're going to be doing there is first we identify the type of the type of inequality that it is, that it's a less than inequality. And so what are we going to do to remove the absolute value? We're going to apply the theorems that we just talked about. And so the first thing is we're going to remove the absolute value. So to remove the absolute value, we're going to take this and we're going to consider both the positive and the negatives automatically with the type of sign we have. So we're going to have, since it's a less than, we're going to do -1 is less than 3x minus 7 is less than 1. So -7 less than 1. And so again, because it's an inequality that has a less than sign, then we separate it like that. Now, would you agree that removing the absolute value, the way it is there, we can solve it like any normal inequality. Now, the rest of what we do from this point on is like solving any of the inequalities that you already did in homework, in the previous homework test. So what do we do here? It's -1. I'm going to add the 7 on each side. It's going to be 6 less than 3x less than 8. It's going to be equal to 6 divided by 3 less than x less than 8 divided by 3. And in the end, what we're going to have is 2 is less than x less than 8 divided by 3. Okay. And so if we represent that as an interval, it would be from 2 to 8 divided by 3. And if we represent that as in the number line, I'm going to be doing the number lines just so we identify how, again, how it looks, how the less than and the greater than absolute value inequalities look. So there's going to be a 2 here and an 8/3 here. And so the solution is going to be open interval here, open interval here, and it's going to be all the numbers in between these two. Okay, questions with this one? Okay, the key is to remove the absolute value. Once we remove the absolute value, it turns into a normal inequality like the ones you've already been working with. Yes, go ahead.
I don't know if it was a influence, but I feel like at the beginning, like 3x on the 7 equals to 1. Then I did all the figure, and I had the same results, but with the sign like change.
Converted.
Yes. I don't know if it was like a coincidence or.
So when you say, well, first, when you say signs changed, do you mean the inequality signs or the?
In the final result,
Uh-huh.
I have like I get -2.6, but in the
8.30 divided by 3. Uh-huh.
and it's less than x greater than 2.
Oh, yeah, you got the same thing, but you got it flipped.
Yes,
It's the same result.
and it wasn't a coincidence.
No, it's I'm not sure what you did, but if I'm understanding correctly, again with the names, because I'm going to be very bad.
Well,
Coil. So if I'm understanding correctly, Coil, what you got was 8 divided by 3 is less than x less than 2.
yes.
That's it. That's equivalent to what we have in the bottom.
Oh,
It's actually we're just flipping it without changing the sign, so it's equivalent.
okay.
Okay, good. Okay, questions with this one? Okay. I'm going to give you a few moments to solve that one.
Teacher,
Yes,
can I send you a picture of one of the answers?
yes, go ahead.
It's the second one, this example, the one you're just showing. Is it like that?
Okay, let me check.
Oh wait, I think I made a mistake with the sign. No, wait. No, I didn't. Never mind.
Hmm.
It just stays like that, right? Because there's a
Yeah.
0 at the end.
Yeah, because if we put the 0 on each side, it's
The same thing.
Yep.
Okay, thank you.
Well, actually, the value is correct, but we're gonna make a note right now that has to do with the trick problem that we just mentioned.
Okay.
Okay, the value is correct, but we're gonna make a note here having to do with the trick. So this is another one that's kind of, we have to look at it before we solve it. So we're saying that 2x minus 5 is going to be less than or equal to 0. Less than or equal to 0, this means that this inequality is going to be negative or 0. If it's an absolute value, can it be negative? No, it can't be negative. Again, it's impossible. This is impossible. But this 0 is possible. Because we mentioned in the theorems that an absolute value can be 0. Okay. So what are we going to do to find the solution set for that one? We solve it normally. We're gonna express this as an equation because we're just looking for the 0 value. So this is actually going to turn into 2x minus 5 is going to be equal to 0. This is going to give us 2x is equal to 5. X is equal to 5 divided by 2. So in this case, the solution set is not going to be a range of numbers. It's going to be just one number. Again, these are some of the things we have to keep in mind. Did you see that, Marco?
Excuse me, can you say it again? I think I cut out.
Yeah, no, I just mentioned, did you see that, or do you have questions, Marco? So your value was correct, but we don't consider the less than or because it's never going to be negative.
Oh, okay, because of the absolute value.
Correct.
Okay, thank you.
Teacher,
Yes.
why did the sign turn into an equal sign?
Okay, because the original inequality says that we're looking for values that make the absolute value negative. Now, we had just mentioned that, again, an absolute value can never be negative. So the original says less than or equal, which is negative, and this can never happen. And so we're only interested in the values that are equal to 0. That's why we're changing it to this. The less than values or the negative values, those values are impossible. The absolute value is never going to be negative. And so we only need to find the value that makes the expression 0. That's the one that's going to be part of the solution. Okay, is that clear, Alfredo?
Yes, teacher.
Okay, thank you. Daniel, go
For
ahead.
example, I still solved it as an inequality and it gave me 5 halves less than equal to x and less than equal to 5 halves. That's still the same. because
Yeah, technically, so
that's the range of numbers,
it's only that number, yeah. So what you did is that you separated this into you separated into 2x minus 5 is less than 0 and 2x or equal to 0 and 2x minus 5 is, no, I'm sorry.
I did, 0 is less than,
You separate it into 0 less than or equal to x minus 5 less than or equal to 0. And if we solve this, this is going to be 5 less than or equal to 2x less than or equal to 5. 5 is 5 divided by 2 is less than or equal to x less than or equal to 5 divided by 2. So basically that solution is telling us that it's between this number and the same number, which is that number. So actually, if you did that and just put the solution as x equals 5/2, it would not be incorrect. Okay. Yes, somebody at home wanted to ask something. Go ahead.
No, nothing. I just said that I also did that.
Yeah, if you did that and got that interval, the only thing you would need to infer is that from this. So let me just write this down so I can take a screenshot. That's a solution applying directly the rule. And that would not be incorrect. The only thing you would need to infer is that this interval that results is the same as saying that it's equal to 5 divided by 2. But yeah, if you did that, technically it wouldn't be incorrect. We just need to interpret it. So this turned into this, and the only thing we need to understand is that this represents this. Okay. I'm just going to write this down here as alternate. Okay. So technically that wouldn't be incorrect. The only important thing here is the interpretation. So you get that interval and you need to extract from that interval that's really not an interval, it's that point in the number. Okay, questions with this one? Pretty good on time. Okay, let's try to do one more. Now try that one out. That one's different. It's not less than, it's greater than. Oh, I see your trick.
Entonces, no, vamos a las fotos, ¿verdad?
entre 1, qué malo que
So in this case, since it is larger, In this case, since it's larger than, or rather larger than or equal, then we're going to separate it into the scenario with the negative and the positive. So this one separates a bit differently than the less than. What's going to happen here is that we're going to have 4 minus 1/2 of x is larger than or equal to 7. And we're going to have over here 4 minus 1/2 of x is less than or equal to -7. Bless you. And so, because it's larger than or equal, we separate it into the extremes of the negative and the positive, and then each of these inequalities, we solve them separately. So this is going to be the same as having 1 divided minus 1/2 of x larger than or equal than 7 minus 4. 1/2 negative of x is larger than or equal to 3. Then we multiply by 2 on either side, and that's going to give us a 6. But since a -6, but since we're multiplying by a negative number, the sign is going to flip. And remember the flips of the sign, okay? Because we're multiplying on each side by -2. Over here on this side, we're going to have minus 1/2 of x less than or equal to -7 minus 4 minus 1/2 of x less than or equal to -11. We're going to multiply by the -2, and this is going to give us x is 22, but it's going to be larger than or equal to. So we have to remember about the sign changes. And so here the interval is going to be from -∞ to -6, including the -6, union with 22 to infinite. And if you represent that in the number line, we're going to have a 22 here and a -6 here. So the interval is going to be a -∞ to -6. With a bracket and larger than 22. Okay. So what's going to happen there is that when it's less than, we're going to get a closed interval between two numbers. And when it's greater than, we're going to get an open interval between two numbers going less than or greater than. Okay. Questions with this one? Okay. Once we understand how to remove the absolute value, then the rest of the solution is just a simple inequality. Questions with this one over at home?
No.
No.
Okay, good. Okay,
Oh, teacher.
yes, go ahead.
when you're trying to make the
Miguel, is it-
division on the
is it
left.
Miguel? I'm sorry, is it Miguel?
Yes.
Oh, please turn on your camera so you pop
Oh,
up.
okay, sorry.
I can see you. That's fine. Go ahead.
Okay, so in the division on the 1/2,
Yes,
when you turn it to the other side, you have to turn the signal around, the inequality.
yes, because we're multiplying by -2. Remember that we flip always when we multiply by a negative number.
Okay, so if it
A
wasn't
multiplier
a
divider.
negative number, you wouldn't have to
Yes.
do it.
Always when we multiply or divide by a negative number, we have to flip the sign.
Okay, thank you.
Good. Thank you. Any additional questions before we wrap up? Okay. Okay.